Hello, ladies and gentlemen. It's Mrs. Notzel, and welcome back to another week of e-learning. Last week, we worked with statistical data, and we were working with how when we ask certain questions and when we ask statistical questions, those provide data that has a lot of variability. So when you ask a statistical question, there's a variety of answers that you can have. It doesn't just give you one exact answer. So today we're going to continue. This week we're going to continue looking at how to represent the variability in data. So I went ahead and put this in a Google slide just so that I could kind of walk you guys through how to do this. I know that you guys worked with it for the first time last week, but what I do when I'm working in a Google slide like this, the first thing I do is I go over here to view and I just go into Zoom and I hit zoom in, and then it's right there so that I can see it much better. So what we're going to be doing is we're going to be looking at this first problem. It is on page 306 in your books, but you can just follow along here for right now because all we're doing is introducing the lesson. So it says students in band, chorus, and strings classes collected donations for a fundraiser concert to raise money for the music program. These line plots show the results of asking 10 students from each class how much money they collected. Okay, so what is this problem about? This problem is about raising money, right? And it's about the different classes. So what information is important? It's important to know that there's 10 students and that there's a band, a chorus, and a strings class. And then what are we trying to find out? We're trying to find out how much money was collected in each class. So this first line plot, okay, remember a line plot just gives you the data. So there's 10 people that they were surveyed, so there's going to be 10 X's, and then the bottom row tells you that this is how much money was collected. So there was 1, 2, 3, 4, 5, 6 people that collected $10, okay? And so the band looks a little bit different than the chorus, and then the chorus line plot looks a little different than the strings. And so we're going to use the shape of each line plot to explain how the data varies. All right, so let's look at this first problem right here. Between what numbers are the most common responses for each group of students? Okay, so I'm going to go up here and I'm going to get a text box. And I'm going to make a text box here so that way I can type. That's not a very good text box, but I can make it bigger. Okay, so then when I click in here so that I can type, it says what the most students. So I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 students between 10 and 20. So I would put 10 to 20. Okay. Then we can look at the chorus and we can see where is the most students. Well, our most students are from 10 to 30. So I'm going to click on the text box again, and I'm going to click on here and get that text box again. And then I'm going to type on there and I'm going to say 10 to 30. Then when I look at the strings, I'm going to see that most of it is between 40 and 60. So I'm going to put a text box here and I'm going to put a text box here, like I said, and I'm going to put 40 to 60. Okay, now our next problem says, based on the line plots, which class likely raised the most money? Okay, and we have to explain our answer. So I'm going to first insert my text box, and then I'm going to answer the question. All right, so based on the, I'm going to say strings class raised the most money because most of the students collected between $40 to $60, which is the most money collected on any line plot. Okay, so do you see how the majority of students here collected 40 to 60? So just by looking at the data without even having to add anything up or use the numbers or anything like that, we can tell just by looking at the line plots. All right, now the next one says, based on the line plots, which class likely raised the least money? Okay, so now we're going to put another text box and we're going to explain here. And we're going to say band earned the least amount, raised the least amount of money because the majority of students only raised $10, which is the least amount of money. Okay, now the next one says, do you think these graphs would look different if 10 different students were surveyed from each class? And because this is a statistical question and because it has a lot of variety, if we ask 10 different students, I think that the data is going to be different because there's going to be a variety in the data, okay? So I would say yes, because of the variety of answers from 10 different students. Okay, so we have looked at these 3 line plots. We have observed them, and we have answered some questions about them. Now we're going to learn a little bit more about the vocabulary. So on the previous page, you looked at the shape of each line plot to think about what the data means. You observed that the data for band were clustered around lesser values, and the data for strings were clustered around greater values. A cluster of data is a group of data points that crowd near each other. Okay, so this right here is a cluster. This right here, the 10 through 30 is a cluster. This right here, the 40 to 60 is a cluster. Okay. And then these are some different terms about data that you need to become familiar with. A graph is skewed left when most of the data points are clustered near high values. So this graph right here would be known as skewed left, which is kind of confusing because it looks like all of the information is on the right, but it's actually skewed left when most of the data points are clustered near higher values. A graph is skewed right when most of the data points are clustered near lower values. Okay, so this one is skewed right. Symmetrical graphs have the same shape on either side of a middle point. So this graph right here is a symmetrical graph. A peak forms when many data points are at one value. So we have a peak here at 10, and we have a peak here at 20 on this data. This one doesn't have a peak because it doesn't have one data point that has more. An outlier is a data point far away from the other data points. It doesn't quite fit with the rest of the data points. So these two kind of right here are outliers because most of the data is right here. Okay, now the question says, can an outlier value be part of a cluster of values? And it says that the outlier is a data point far away from the other data points. So if it's far away from the other data points, then it can't be part of the cluster, because a cluster is when all of them are clumped together, okay? So your answer here would be no. Okay, this would be no. An outlier is a data point far away from the other data points, and a cluster is all the points together. Not all the points together, but it's a group of points clumped together. Okay, so something else that I want to talk to you guys about. So that is how we look at data and some of the vocabulary that we use to describe the data and to interpret the variety or the variability in data. Something else that you're going to be working on in is something that we've also worked on before. And I made like a little anchor chart in its mean, median, mode, and range. And so I have a set of data that I want to go over with you guys. So I'm going to change my screen. And I have my data here as 8, 8, 9, 4, 9, 8, 10. So when you have to find the mean of a set of data, and I'm going to post that anchor chart so you guys can refer back to it. The mean or the average is when you add up all of those numbers. So you would say 8 plus, oops, I didn't mean to do that. Sorry guys, 8 plus 8 plus 9 plus 4 plus 9 plus 8 plus 10. Okay. And I'm going to pause so I can give you guys a chance to kind of add that up. Okay, so hopefully you guys added it up. I grouped all the 8s together because I know that 3 times 8 is 24, 9 plus 9 is 18, and then I did 10 plus 4 is 14, and I got a total of 56. So this data equals 56. And then once you find the sum, then you take the sum and you divide it by the number of numbers in the set. So we would take 56 and divide it by, we have 1, 2, 3, 4, 5, 6, 7 numbers in that set. So we take 56 divided by 7, which equals 8. So the mean or average of this set of data is 8. Okay? Then our next term is the median. A median is your middle number. Okay, and the median is the middle number when you write the numbers in numerical order. So we would have to write 8, or I'm sorry, we'd have to write 4, 8, 8, 8, 9, 9, and 10. So when we look at that, we see that we have 1, 2, 3, 4, 5, 6, 7. So if we count 3 in on each side, then we see that our median is also 8. Okay. Then we look at the data and we see what the mode is. The mode is the number you see the most often. Okay. And the mode is 8 because when you look at the data, you see 1, 2, 3, 8s. Okay. And then the range is the difference between the largest number and the smallest number in a set of data. Okay, so the range, when you look at our data up here, our biggest number is 10 and our smallest number is 4. So we would take 10 minus 4, which would equal 6. So our range is 6. Sorry, my son just came in here, so that's the shadow that you see on the wall. um, so that should help you with the information in the next couple of lessons that you're going to be doing. So what you're going to be working on Monday and Tuesday and Wednesday. And then there was just one more thing that I wanted to show you or go over with you guys in this video. Okay, so we've already gone over 306 and 307, mean, median, and mode you're going to be working on. But in this variability, I wanted you guys to look at, okay, so we just went over range. Range is the difference between the greatest and least values. So we just went over that. But I wanted to go over this MAD with you. Okay, MAD is the average of the distances of each data point from the mean. Okay, so they're doing the data from the band. Okay, so I'm going to talk about this. Okay, the data value, we had 10, 10, 10, 10, 10, 10, because we had 6 people that collected $10. Then we had 2 that did 20, 1 that did 40, and 1 that did 60. Okay, so it gives you instructions here. So you find the deviation. The deviation means the distance of each data value from the mean. When you add all of these up and divide them, your mean is going to be 20, I believe. And so since the mean is 20, the value, the distance from 10 to 20 is minus 10. Okay, but then you take the absolute value of that deviation and you get 10. Then you look at this one, and so all of the 10s are 10 away from 20. Since the mean is 20, on your data value of 20, there's no deviation, there's no distance from the mean. And then when you get to 40, there's 20, there's a difference of 20. And then when you get to 60, there's a difference of 40. So then when you take the absolute value of all of those and you add them all up and you divide by the number that you have, you're going to get a score of 12. So the MAD of 12 means that on average, every data point is $12 from the mean. Okay, so you might have to work with this, and I wasn't sure if we were going to do another video or not, so I wanted to at least talk about it. If you have any questions, please feel free to reach out to Miss Walker or myself via Google Classroom, Google Hangouts, however you need to get in touch with us. Okay, good luck. I know you guys are going to do great, and I hope that you guys have a great week. Get that e-learning done. All right, talk to you later. Bye-bye.